Module 7, Investigation 9, Inverse Trigonometric Functions. Complete the function machine diagrams below. So this is like our input. Our input into the function is the measure of an angle. And then like over here, like what comes out of the function. And really, like we should put the measure of an angle like outside, like, oh, here it is coming through. And then what comes out is the vertical distance between the horizontal diameter and a point on a circle. Yeah, that should be the output here, which there's no room really to put this. Anyways, the domain of the function is all real numbers. We can put any real number into any real angle measure into our function, and the range of the sine function is just from -1 to 1. It doesn't get any larger than that. If you wanted to get larger than that, you have to multiply by a radius, like r sine theta. But on the unit circle, the vertical distance varies between -1 and 1. These are the same. Let's see. For each of these, we're inputting an angle measure. For this one, for the cosine function, and for the tangent function. Yep, this is getting pretty messy. Anyways, if you input that into the cosine function, what comes out is the horizontal distance from the vertical diameter to a point on the unit circle. The domain is again all real numbers, and the range is just like the sine function, -1 to 1. For the tangent function, the domain is not all real numbers. It's kind of weird. It's all reals except those values that give us vertical asymptotes. Which are just multiples of pi over 2. Let's see. So pi over 2 plus kn, where k is an integer. So if we take pi over 2 and we add pi, then we get to another one that's not possible. So that's our domain. And then the range is actually all real numbers. Remember that tangent graph, it extends from -infinity to +infinity. So sorry for the messiness there. I guess that I should have planned that better. What is the input quantity for the inverse relation of the sine function? Angle measure. What is the... Oh, wait a second. I guess that's wrong. It said the inverse relation. Oh. So, if I go backwards, remember the inverse function undoes what we've done before. So the domain of the inverse function is the range of the original function, and vice versa. So what we're going to be inputting into the inverse function will be what we output in the sine function, vertical distance. We could be a little bit more specific here. We have a little bit of space. Vertical distance from where the terminal ray intersects the unit circle, and again above the horizontal diameter. And then for the inverse relation, we're going to be outputting a angle measure. Is the inverse relation of the sine function a function? That is, does each vertical distance above the horizontal diameter produce a unique angle measure? The answer is no. They're like, given a vertical distance, there are several possible angles. So for each input, there is not exactly one output. When considering the inverse sine function, we first restrict the domain of the sine function to theta between negative pi over 2 and pi over 2, and then consider the inverse. By doing that restriction, we eliminate the problem of more than one output for each input, because we're just looking at a portion of the unit circle, the right hemisphere, quadrants 1 and 4. The inverse sine function takes as its input the vertical distance from where the terminal ray or of the angle intersects the unit circle above the horizontal diameter and outputs an angle measure. We call this inverse the arcsine or inverse sine function, and write arcsine of y equals theta, or sine inverse of y equals theta. Let's see, so then there's the inverse cosine function. We restrict the domain theta to be between 0 and pi. The inverse cosine function takes as its input the horizontal distance from the terminal, where the terminal ray of the angle intersects the unit circle, to the right of the vertical diameter and radius lengths, and outputs the angle measure. We call this inverse the arccosine or inverse cosine function, and write arccosine of x equals theta, or inverse cosine of x equals theta. When considering the inverse of the tangent function, we first restrict the domain of the tangent function to thetas between negative pi over 2 and pi over 2, and then consider the inverse. The inverse tangent function takes as its input the slope of the terminal ray and outputs an angle measure. We call this inverse the arctangent or inverse tangent function. Okay, complete the following function machine diagrams. I'm going to give myself some room here. For the inverse function, I input vertical distance above the horizontal diameter, and my output is angle measure. The domain, we restrict that vertical distance so that the domain is from, let's see, well, actually the vertical distance we know can only be from negative 1 to 1. And that means that our range because of the restriction that we made is only between negative pi over 2 and pi over 2. For the cosine, we input horizontal distance, and our output is angle measure. The domain, the distances range from negative 1 to 1. That's our domain. And then the range, we're restricting this function so that the range is always between 0 and pi. That makes sure that for each input we have only one output. Okay, so then for the inverse tangent function, we input the slope of the terminal ray of an angle. Our output is the angle measure that results in that terminal ray. And the domain is actually all real numbers, and we restrict the range just from negative pi over 2 to pi over 2. Demonstrate on the following circles how one could estimate the value of inverse sine of 0.25. Okay, so 0.25 is a vertical distance. And this is the point on our unit circle where the vertical distance is 0.25. So what we're looking for with the inverse sine function is the angle that results in that vertical distance. Well, to me, I'm looking at that angle theta here, and it looks like theta is about 20 degrees to me. If you type S inverse of 0.25 in your calculator, you'll get 15 degrees approximately, or 0.25268 radians. So those are exact. Let's see, you could also you might want to notice that this is the same vertical distance here, so we could consider the angle that goes like all the way around, but with the inverse sine function we restrict the domain so that we only care about these this right semicircle, so that we don't have multiple values with the same multiple inputs with the same output. Okay, for this circle it's a little bit complicated. If we just look at inverse sine of 0.25, that's 15 degrees, but that's only for the unit circle. If we have this radius with length 5, it's a little bit different. So our radius is equal to 5. Notice if we multiply 5 times 0.25, what do we get? So if we take 25% of that radius, we get 1.25. Because the sine function always outputs the percentage of the radius that the height is. So really what we're looking for is at 1.25, what is the height? And of course in this situation 5 times sine of theta would give us 1.25. And so sine of theta would be 1.25 over 5, and then theta would be the inverse sine of that, which is just 0.25, and we'd get the same radian measure, 0.25268 radians. Using the following circles to estimate the value of inverse cosine of negative 0.75. Explain your approach, then use your calculator to evaluate inverse cosine of negative 0.75. Okay, so cosine, we restrict the domain from 0 to pi. Negative 0.75 is this horizontal distance here, which will correspond to this point. Note that this position is negative 0.75. that's the horizontal distance there, and it corresponds to the angle with the terminal ray at this point. This is our angle that we're looking for. Let's see, to me that looks like 45 degrees past 90, or I can just add those together. $135 degrees, I think. I think that's also 3 pi over 4 radians. If we use the calculator, inverse cosine of negative 0.75, okay, this one comes out to be 2.41886, which is pretty close to what we had found, which was 2.35619. On the circle to the right, inverse cosine of negative 0.75 should come at the exact same relative location. So theta is going to be exactly the same. The thing is, though, your function phi, or cosine of theta, will give you that x value of negative 0.75, and so cosine of theta would equal negative 0.75 over 5, and so theta would be the inverse cosine of negative 0.75 over 5, which is the same thing that we would get 2.41866 radians. In the following circles, how could one estimate the value of inverse tangent of 2? Use your calculator to evaluate this. So if tangent of theta equals 2, then the slope of our line, or sine of theta over cosine theta, has to equal 2. Where would this happen? Like if we went up 2 over 1, don't even have 2 to go up, so let's try up 1 over a half. Up 1 over a half. This would be where my line would be pointing to. So the slope of this line is 2. So what would this, no, that's totally not right. The slope of this line going through the center, that's 2. Notice that would go up 1 over 0.5, and that's y over x would be 2. So what we want to know if we're finding the inverse tangent of 2 is what is this angle theta here. And just looking at the picture, to me it looks about 80 degrees. Let's take a look on our calculator. Inverse tangent of 2. .0715 radians, and if we multiply that by 180 and divide by pi, we see that it's about 63 degrees. Okay, I was way off. It would be exactly the same for this one, but you couldn't think that you could just use a line with a slope of 2 units, because it has to be in terms of the radius. Like our slope tangent theta has to mean that for every 2 radius lengths we go up, we go over 1 radius length. So if we go up 10, or if we go up, if we go up 1 radius length here, then we have to go over a half radius length, which would give us the exact same line, the exact same value of theta. Savannah is sitting in a bucket of a Ferris wheel at the 3 o'clock position. The Ferris wheel has a radius of 62 feet. The Ferris wheel begins moving counterclockwise. What angle has Savannah rotated from the 3 o'clock position when she is 42 feet above the horizontal diameter of the Ferris wheel? So at some point we are 42 feet above, and we want to find out what is the angle there. So notice that 42 feet, like I want to think, what is the percentage of the radius that 42 feet is? 42 feet divided by 62 feet. Essentially we are, that vertical distance is 67% of the radius. So what we're really looking for is the inverse sine of 67%. We could have just put inverse sine of 42 over 62. 0.744249. Did that answer the question? Yeah, that's the angle theta. Now you could say, but wait a second. When she's over here, she has the same vertical distance. So what would be the angle theta that would give us this position? Well, good question. The answer is you can just add or take pi. So here's pi radians this far around, and we know that this one here is the one that we know already, and so if we take away what we found from pi, then that gives us the answer. So I'm thinking about how to make this make more sense. 2.9 or 397 radians. Okay, I think I got it. If you think about the circle, like the argument is, okay, we can have the same height on this side as we do over here. Now, the angle that we sweep out that angle right here is the same as the one that is right here, but it's just in a different location. These angles are equal. So I really want to find this angle here relative to the 3 o'clock position. To do that, I can take pi, which is all the way across, and subtract the little piece and get the answer. So there are two angles for this solution, 2.379 radians and 0.744249 radians. What angles has Savannah rotated when she is negative 20 feet to the right of the vertical diameter of the Ferris wheel? Okay, here's our vertical diameter. And if we're negative 20 feet to the right of it, first of all, I want to figure out what percentage that is of the radius. Negative 20 over 62 it's about 32%. Okay, so there's going to be two positions where the distance to the right is negative 20. These two. Now this one up here, we can find this point using the inverse cosine of negative 20. Never mind, can't do that. We have to do in terms of the fraction of the radius, negative 20 over 62. The calculator gave me an error there, and so this is 1.89952 radians. That's one of our solutions. Now to find this other one, note, let's see, what should we note here? That if we had gone like all the way around this way, let's see, this angle is also is negative 1.89952 radians. So if we just take 2 pi all the way around and subtract 1.89952 radians, we'll get the other angle that we're looking for. Four point 38367. Radians. Number 6. Determine the measure of the angle theta in radians indicated on the circle. Alright, let's see. There's lots of different ways to do this. I noticed a couple things that may be important. From this point we can see the radius of the circle is 6. Then we have the x-coordinate here, which is a horizontal distance, and the y-coordinate is a vertical distance. One thing we could do is look at it in terms of our inverse sine function. The inverse sine function, which is restricted from negative pi over 2 to pi over 2, could help us here. We know that this point is actually just positive 4.885, and it's also negative 3.484. So what if we did the inverse sine to find this angle? take the inverse sine of negative 3.484. Well, we wouldn't get anything at all because we have to divide this by 6, the radius. So doing that, I get negative 0.619547 radians. Okay, that means that this angle right here is 0.62 radians also. And if we take pi radians and add it to 0.62, then we'll find the angle that we're looking for. .76 radians. A skier skied on a circular trail starting at the position 2.50 on the circle and ended up at the position negative 2.3775, 0.7725. How many kilometers did the skier ski? Okay, so here's a circle. Skier starts at 2.50, 2.5 kilometers is our radius. They ski to this point, which, let's see, negative 2.3775 and 0.7725. Notice that the x-coordinate is negative and the y-coordinate is positive. That's how I know we're in quadrant 2. And we want to know how many kilometers did the skier ski, meaning we're looking for this arc length here. And so we can first find the angle theta, because we know arc length is theta times r, so if we can find angle theta, then we can find the arc length. The interesting thing here is that we have this piece that corresponds to the inverse cosine function. We have this distance here. So if we look at the inverse cosine of negative 2.3775, it will tell us our angle theta. Not really. We have to divide by the radius, 2.5 kilometers. I always make that mistake for some reason. So we get theta is 2.82725 radians. Then if we multiply that by the radius, we get about 7.1 kilometers. So I'm thinking about the reason that I always get this wrong is because if your unit circle, if you don't have the unit circle, then r sine of theta equals y. Meaning if you're looking for sine of theta, it's y over r. Theta would be equal to the inverse sine of y over r. Anytime you're not on the unit circle and you use the inverse sine or cosine, you're going to have to make sure you divide your length by r to get this input in terms of the number of radius lengths. Given the following point on a circle of radius 4 meters centered at the origin, determine the corresponding counterclockwise arc length. Okay. Measure from the 3 o'clock position. So, radius 4 meters, centered at the origin, the point 1.874, negative 3.354 will be down here. And if I want to find the angle measured in radians from the 3 o'clock position. Actually, we want the arc length, but first I need to find this angle. We'll call it theta. Well, there's some sort of good news here, I think. If we look at the inverse sine of negative 3.5 over 4, we get about negative 1.1 radians. What that tells us is that this angle is negative 1.1 radians. So angle theta is simply 2 pi minus 1.1 radians, which is about 5.2 radians. That means that our arc length is 5.2 radians times 4, or 20.8 radians. Nope, that's not right. Sorry, 20.8 kilometers. Still not right. 20.8 meters. Okay. We can probably do something similar with this point. Both coordinates are negative, so we're over here somewhere. This is negative 0.8, negative 0.5. And so, what should we do here? Let's use this negative 0.5, because what we really ultimately want is this angle here. But if we just come over to think about the inverse sine of negative 0.5 for a moment, what that would tell us. Actually, let's make sure that we do negative 0.5. Oh, it's already in radii. That's good, so I don't have to convert anything. This tells me that if we are looking at this same vertical distance here, the angle required would be negative 0.52 radians. So this angle is 0.52 radians, and so we can just take pi plus 0.52 radians to get the entire angle that we need. .6 or 3.7 radians. And then we just need the arc length, so we'll multiply 3.7 radians times 4 meters. .8. I apologize, this has been a pretty sloppy lecture. Yeah, so I'm not sure what they want. You could have said your answer was 3.7 radii. I think that's the answer the book wants, actually. And we can see that that's the number of radians we have, and that corresponds to the number of radii that we cut out on the arc length. Number 9, determine values of theta between 0 and 2 pi that make the following statements true. If there are no such values of theta, say why not. Let's see, so here we need cosine of theta equal to 1/3. If we look at the inverse cosine of theta, inverse cosine of 1/3, that tells us one particular angle theta where the horizontal distance is 1/3, and there's another one though down here. So what's this angle all the way around? It's simply 2 pi minus 1.23. .05 radians. Two answers for this one: 5.05 radians and 1.23 radians. Part B, cosine theta would be equal to negative 0.8. We can again look at the inverse cosine. And we get 2.5 radians. And that just means that, well, if we go 2.5 radians, like over here, we have one solution. But there's another solution over here. And so again, we can just take 2 pi minus 2.5 radians. We get 3.78. So 3.78 radians and 2.5 radians. Okay, cosine of theta here would be equal to negative 1, and I know where that happens on the unit circle only once, when theta is equal to pi radians. Kind of like these other questions, we've seen that the answers, there's two answers if we do 2 pi minus the other answer, but here if we do 2 pi minus pi, we get the same answer. Let's see, sine of theta equal 1/2. Well, I already know the answer to this one. Pi over 6 and 5 pi over 6. That's because I have the unit circle memorized. But let's think about how to do this. If you didn't have that memorized, you could look at the inverse sine of 1/2. My calculator says pi over 6. It also says 0.523599. Let's just use pi over 6. Then if we look at the unit circle, that just means, okay, we're at 1/2 right here at theta equals pi over 6. Notice we're also 1/2 over here on this other side. The vertical distance is 1/2. And that would just mean there was pi over 6 right here. So we just have to take pi and subtract 5, or just pi over 6, and we get 5 pi over 6. So that's the pattern that we could use for all the rest of these problems in this row. Find the first angle using the inverse sign, and then take pi minus that angle. I think that might work. Let's see. Here we can say the inverse sine of 0.8 is 0.927. And then if we take pi minus 0.927, we get 2.21459. We could check to make sure those work by taking the sine of each angle. Sine of 0.927 equals 0.8, and sine of 2.21459 also equals 0.8. So those are both correct. Here, if we multiply both sides by 3, we'll get sine of theta equals 1.5. And that's impossible, because the sine of theta is always between -1 and 1, because it's a proportion of the radius length. Okay, if tangent of theta equals 1, that would mean the slope of the line of the terminal side would have to equal 1. That would happen at 2 places, right here for this angle, then if we went all the way back around to this one. The first one we can find just theta equals inverse tangent of 1. We'll get pi over 4. And notice that, let's see, how do we get to the other side here? Notice that it's just like going pi plus pi over 4 to get to the other side, which is 5 pi over 4. For the next one, tangent of 2 theta equals -8/3. We could find the inverse tangent of -8/3, but what that would give us is 2 times theta. I'm going to go ahead and do that. Inverse tangent of -8/3. And then if I divide that by 2, I'll find theta equal to -0.606. And then we can just, what can we do here? Let's see. What does that even mean? Well, this is a problem. This answer isn't part of our solution interval. We just wanted answers that were in the interval from 0 to 2 pi. So what did it give us? It gave us the answer of -0.06, meaning if we go 0.06 this way, then we have this line with a slope of where 3 tangent 2 theta is -8. But you see that we could just take pi away from, or take 0.06 away from pi, or we could just add -0.06 and we could get an answer. Again, I apologize. I've made like 5 of these videos in 24 hours and I'm ready to be finished with them. 2.5 2.5 radians. So there's one solution right here. Then we could add another pi to get another solution. .7 radians. So let's see, 2.4 radians, yeah, those are pretty good, and 5.7 radians. It's also interesting that when we found that negative 0.06, we failed to realize that this is also a solution right here. And to find that one, I think, yeah, that's the one we already got, isn't it? 2.5? Yeah, that's 2.5. But we could have gone like all the way around negative this direction. I guess it doesn't matter. The book shows some more solutions, but I'm not worried about those. Apparently 4.1 radians and 0.97 radians are also solutions. But we'll talk about that in class. Okay, tangent of theta is negative 1/6. So if we found the inverse tangent of negative 1/6, negative 0.165, that's not part of our interval, so we can add a pi to it. And get 2.97. We could add another pi to that. Get 6.118. When will it end? Not in number 10. Yep, number 10. Given the following circle and undetermined angle measures of alpha and theta, answer the following. So what is the value of theta, measure of the angle indicated in the figure above? I don't see a theta, but I'm going to guess that it's this angle here. And to find theta, we would just take our arc length, which is 7.749 meters, divided by the radius of 3 meters. And we would come out with 2.583 radians. What quantity does the value negative 2.914 over 3 represent? Well, that tells you the proportion of the radius that this horizontal distance is. Not that one, this one. Okay, and then what about the 2.046? Well, it represents this vertical distance. Measured in radius lengths. What is the value of alpha? Let's see, my book doesn't have an alpha, but I'm going to guess alpha is right here. So the question is, what is the value of alpha? Well, let's see. We could note that the radius is 3 times sine of alpha gives us 2.046. So sine of alpha will equal 2.046 over 3. We can find alpha as the inverse sine of 2.046 over 3. Which is 0.750 radians. The book has a lot more weird stuff. It says that that's alpha 1. Okay, so what's alpha 2? They took away pi from that number to get this radian. I think they're calling this alpha 2 because they're saying that's pi minus 0.750, which is 2.391 radians. So this was alpha 1, and they say that's alpha. I don't know what they're doing in this book. So alpha 2 is 2.391 radians. I don't know which one of those is your real alpha. And then it has some other crazy stuff, subtracting 2 pi from that. I don't know. You might also have an answer of 3.892 radians. Your books probably have this and you can figure it out, but my book doesn't even have them labeled. Determine the values for x and y. Oh, there it is. X and y. Well, I'm going to add up all my angles together. Alpha 1, 0.75, plus my alpha 2, 2.39, which of course comes out to pi, plus theta, which was 2.583. I get my total angle is 5.723. Okay, so there's theta. That means that x would be, I think the radius of this circle was 3, so 3 cosine of 5.723, and y would be 3 sine of 5.723. Radians, of course, for the angle. And we'd get point. You can see here the answers that I got. Sorry, I don't know what the book's talking about, but it has a different answer. Theta plus alpha, they got 4.974 radians. And then that means that x would be 0.7759 and y would be negative 2.8978.